Hi everyone, and welcome to my another Yolo tutorial. In this tutorial, I will demonstrate you how to use Google Colab. This is actually a Google free cloud service for AI developers. This service will use to train the Yolo v3 custom object detector. With Colab, you can develop deep learning applications on the GPU for free. This doesn't mean that you will be able to train only Yolo model. With the same technique, we can train any model we want. So let's see at first some minor issues of the Google Colab. First, while trying to connect to the GPU runtime, it sometimes throws an error saying it can't connect. That's due to the heavy number of people trying to use the service, but Google plans to add more GPU machines, so it doesn't matter in the future. So sometimes the runtime just dies intermittently. There might be many underlying causes for this. We can't solve, but I think Google will solve this in future. The amount of RAM available is 30 gigabytes, which is too good to be given as for free. But we are talking about object detection, computer vision, and machine learning. So with large models, we might face memory warnings. And fourth, Google Colab is a free service offered by Google, where you can run Python scripts and use machine learning libraries, taking advantage of their powerful hardware. It's for free with the only disadvantage: you can use it for 12 hours in a row. After that, you will be disconnected and your files will be deleted. You can restart it again, but you'll need to do everything from scratch. That's the biggest disadvantage from my list. And the fifth, if we would plan to train a large model, we might face a memory and space issues. To solve 12 hours issue and file loss problem, we can by connecting Google Colab with Google Drive. So we won't lose the files in case of disconnection. In this tutorial, I'm going to explain to you one of the easiest way to train Yolo v3 to detect a custom object if you don't have a computer with a strong GPU. You will need just a simple laptop, Windows, Linux or Mac operating system on it, and as the training is going to be done online, taking advantage of the free GPU offered by Google. We can train Yolo to detect custom objects. So in this tutorial I chose for example to a car license plate, and you can choose any object you prefer. Simply in this part I'm not talking about dataset preparation. You can check it in my 2 previous tutorials. So here's my webpage, and here is 2 my previous tutorials where I showed you how you can prepare your own custom image dataset. Yeah, you can use it. And of course, I will use my same dataset as I used in my last tutorial, where I used to detect a car license plate. And I simply will show you how to train this dataset on the cloud with free GPU if you don't have it on your own. So let's start. First step would be to, as I said, I'm not talking about dataset preparation in this part, but I recommend at first prepare dataset, configure configs.py script and check if training starts at least locally for you. If training works, this means we can move to Google Colab. If you don't know how to do this step, you can check 2 previous my tutorials. Of course, this video will be old after a while, but you can find all links in the video description and on my text version tutorial. It won't be a problem for you. Just check this. Don't write me in private message, because I received too many messages, and in the future I think amount of these private messages will just increase and I can't answer to everyone. So please read my webpage. In the future I plan to upgrade this to add a comments tab somewhere after the tutorial, but this is only in future. So let's move on. For example, this will be that you clone my GitHub repository, you prepare dataset and so on, and there will be a Yolo v3 Colab training.ipnb file, which you will be using to train on Google Colab. And I will add this on the GitHub. It's not yet there yet, but after this recording and within this video, I will add this. So what we should do, At first, I recommend to try everything locally on your CPU. It should work there because this will be much easier to change configurations if you are sure that this repository and training works locally. So when you tested everything locally, move the prepared folder to your local Google Drive directory. This would look following. It's, for example, my drive. This is the name of my tutorial on the GitHub. You just use the same. I recommend, for example, at the first time, use the same as in my tutorial. You must be sure that all images are prepared, configurations changed according to your needs, and training works locally on CPU. So when you see this file, well, we actually open it. We click our right button, we click on Open With, and we use Google Collaboratory. I don't know why, but it takes a little time to open. Next step, we need to enable the GPU. So we click on Edit, Notebook Settings, and as you can see here, you should see GPU. Usually it is the GPU, but don't click on TPU. I haven't tested it, but you can use a GPU. And click simply Save. Now we have selected a GPU and we have a Google Colab opened. What the first thing would be is we just can run our first cell, and this cell will check a GPU if we have a GPU actually, and to the server terminal it will send a NVIDIA SMI command. Let's see what it will give to me. So as you can see, I received a Tesla K80 GPU and with 150 watts, and it's enough for my model. But sometimes I'm luckier and I receive a Tesla P100. It's stronger and has more RAM, but I can't do anything with it. Of course, here is RAM usage and the disk usage. Now we are ready to connect a Colab with our Google Drive. To do so, run the cell where it's written from Google Colab import drive, and then click on the link that appears. So I go here, I run it with Shift Enter, and as you can see, here's a link. We use this link to authorize our Google Drive with Google Colab, and I simply copy this. I go here and I passed the password actually, and it shows me that it's working on it. So this link is used to grant access to your Google Drive. Once you enter it, it asks you to allow the Google Drive file stream. Click on allow and then copy the code that appears. Actually, what I just did. So now our Colab is ready for further use with our Google Drive files. The last step is to open our project directory by running next following step. So I open this, and as you can see, if you are working on Linux, you already know these commands, but if you're on Windows or Mac, you might not saw anything like that. So this is cd command is used to open the TensorFlow 2.x Yolo v3 directory in my Google Drive, as it was here. So if you are using some kind of different name for your directory, or you have more different path, just change it here. And ls is used to show us what files we have in our local directory. So everything is fine here. And to make sure that our Colab has all necessary libraries for our Yolo v3 project, we might install libraries from requirements.txt file. I added it here. Probably now it should be installed because I already ran this before, so I don't need to do that. And as you can see, requirements already satisfied. So I'm not running this in this tutorial. To make completely sure that TensorFlow works with GPU, we can run next cell, which will give us the output of TensorFlow version and visible GPU devices. By the way, I forgot to mention that if you tested everything locally, you already downloaded Yolo v3 weights, but if you for some kind of reason don't have them, you run this cell where you'll download the weights, original weights file. So I'm not running this also. And here is the function. So I'll import TensorFlow as TF and I'll print a TensorFlow version. And of course, then it should print me the devices, visible devices of GPU. And it gives me one device. This means we are running with one GPU within a 0 slot. So actually, we are completely sure that we are having a GPU. So next step is to test Yolo with the object detection on Google Colab. Up to this point, everything worked without any issues. We are ready to test object detection on the cloud. To do this, I copied a code sample from my detections demo Py script on GitHub. And I a little bit modified it. I added some imports and so on, so we'll be able to use it. I run this. Give it a moment. So actually, it imported our Nina libraries. It created a model with darknet original weights. So right now we should be able to test this detection. So with the next cell, I will test detection with the original mode on the kite JPEG image. This is from my images folder. Of course, you can test this with more images and you can upload them here, but this is all images I have for this tutorial and my past tutorial. So actually we'll feed this image there. And what I should mention that you might notice that this function is from my detections demo file, but instead of show, here I use it of false, because on my tutorial for displaying detection, I used OpenCV, and here actually I'll need to use a matplotlib to plot an image. So maybe in the future I will implement that, for example, to choose what we use to plot an image, OpenCV or Pillow or matplotlib. So for this tutorial, because we are on Notebook, we should use matplotlib. With OpenCV there is an issues and we can't properly show our image. So actually I'll run this script and it will run a detection for us. And the minus is that we can of course run a real-time video detection, but there is some difficulties to implement this kind of function. So simply we don't care. We mostly use Google Colab for training detection model. So actually, as you can see, it worked and it actually detected kites and the persons. So that's it. We are sure that our model works. You can input another image, for example, which would be more interesting is street JPEG. Okay, I can write street JPEG. I'll run this. Yeah, it worked, and as you can see, it also detected a person, car, bus, and so on, a lot of objects. We are sure that our model is working. So next step is to train our v3 custom model. First, because our dataset location changed from what we had in our annotations file, we should run XML to Yolo v3 script. Again, to convert XML files to Yolo v3 annotations file according to our new location in Google Drive. To do that, we run simply a following cell. So I can run this for you, and this will do all the hard work for me. And keep in mind that on the drive, everything is a little slower, and it might take more time than you train locally on your local GPU, but for those who don't have a GPU, it will be a lot faster. So actually, we don't need to wait to finish here. So, or we do. Yeah, we do, but doesn't matter. There is not a lot of images. And actually, after it finished, we are ready to start the training process with the following cell. And here I simply import my train function from, my main function from train script, my main folder where I do the training. And this is used to clear the backend sessions of test detections, and that we would be able to train a new model actually. So let's wait for this script to finish and I'll show you how everything works. Well, actually, I don't need to show you how it trains because there is few history steps actually, and I just need to mention that the first epoch might take longer, but don't worry, the training process will get momentum after a few epochs. While training, the model will be saved in the checkpoint folder. Later you can download the files and the test custom detection locally. So actually I can show this for you, that all models will be saved here on the checkpoints, and actually you need all these files download to do the detection differently from the TensorFlow 1. For example 15 version where we had a H5 file. Now we use a 3 files. Well, actually I'm new to TensorFlow 2, so I'm not actually sure if we can do this with H5 model, but I think there should be some kind of possibility. So it's still working with my images. The disadvantage with Google Colab training is that I can't open a TensorBoard to check how my training process is performing. Maybe later I will implement a custom graph plotting if there will be a need. Now it is how it is, and actually I can't do anything. As you can see, it finished a conversion for our annotations, and there is only one class license plate, and we can use this training. And actually after all validation, there will be after all steps there will be a validation step with total validation loss, and by default it's configured to save a best model according to total validation loss. So this we were tracking on the TensorBoard, and actually right now we can't, but as you can see it keeps decreasing, and it doesn't matter how long, but we are sure that our model will be saved only the best, because I choose to save it according to the best total validation loss. If the total validation loss is worse than before, we are not saving the model, so because it is overfitting. We don't want that to be true for us. So actually I'm not showing you all the steps how it was training. Let's move on. After a while, when it finished training, we are sure that our model is trained. So it's time now to test our custom model. By the way, while training, our browser can't be closed, so keep it open. What I'll do, I create Yolo v3 custom model and load custom trained weights to it. Same as before, as I used to load original weights, this time I'm loading our custom weights. So I run this command, and this is only for testing purposes. And actually I can run that test the detection with named plate2 JPEG image. And here actually I have everything the same, show equal to false, and I'm not saving a detection image, and actually this image I'm testing on. So actually this is my history, and I wanted to be sure that everything works on this Google Colab, so that you can simply download and run all cells one by one. So actually I can show this to you, and I'll run this model, and you'll see that the detection works, and actually it sees the license plate with 0.83 accuracy. And I have one more image which I tested before, and it's plate 1. We can run this plate 1, and let's run this. It's working, and it wasn't so hard to train our model. And that's it. What I can say, so I can say that you just train your first Yolo v3 custom object detector on Google Colab, and good job. Now you can download custom trained model and run it on more images, on videos, or even on webcam detection. That's it. So what is the limitations of Google Colab is that if you have a very large data set, make sure that it's enough with memory, because you must fit to this. It should be enough for you, because it's no other way to do this, or you'll need to buy more space on the Google Drive. It's quite expensive. Here is another solution, that there is a RAM, and of course I implemented by default into configurations that I load all images to RAM before training. So if you have a lot of images which takes a lot of RAM, keep in mind, change this configuration. Sorry. So that's it for this tutorial. As you can see, it works, and you just trained your first Yolo v3 model. Good job! To the end, I must mention that Google is really helping to reduce the entry barrier into deep learning, and a tool like this will help many people who can't afford a GPU resource. I really hope that this will be fully scaled service soon and remain free. I hope this tutorial was useful for you, and I could help you to learn something new. If you like this tutorial, give it a like, subscribe my channel on YouTube, and see you in the next part, of course. There is a lot I will show you in the future. So that's it, and goodbye. See you later.